What you've just seen is the way zinc's been produced for the last 100 years. The method used is called horizontal distillation, a process prodigal of time and toil, dirty and uproarious, demanding much and giving grudgingly. Therefore, this horizontal distillation plant at Swansea Vale was closed down in March 1960. This is the new zinc smelting plant at Swansea Vale. It employs the Imperial smelting process developed during 20 years of research by metallurgists and engineers of Imperial Smelting Corporation at Avonmouth. The process, producing zinc and lead, is entirely new, making smelting more economical and more flexible by using a single unit instead of scores of tiny retorts. Smelting takes place in a blast furnace, which requires controlled supplies of lump sinter and metallurgical coke. The coke must be preheated to 800 degrees centigrade. In readiness for this, the coke is first fed to the coke preheater by a skip hoist. Blast furnace gas produced in the process is used for preheating the coke, being burned under carefully controlled conditions and in contact with the coke. After heating, the coke is discharged from the bottom of the preheater shaft via a vibratory feeder to an automatic system using strain gauge weighing. Sinter, the other raw material, preferably delivered hot from the sinter machine, is similarly fed into the charge bucket. The electronic weighing system, which measures the quantities of coke and sinter, is entirely automatic and ensures accurate proportioning of the charge for the furnace. The charge of sinter and coke with any required flux additions is transported to the top of the blast furnace and is fed into the furnace shaft through a double bell system. For the sake of clarity, in the following animation, the continuous operation of the process has been broken down into its various stages. The shaft of the Imperial smelting furnace is basically similar to that of an ordinary lead blast furnace and has water-cooled jackets with brickwork lining above. Air, preheated by blast furnace gas to 750 degrees centigrade, is used for smelting. The heated air is blown into the furnace shaft through water-cooled tuyeres. In the blast furnace, the combustion of coke produces a gas mixture rich in carbon monoxide, which, as it passes upward through the charge, reduces the zinc and lead oxides contained in the lump sinter to zinc vapor and liquid lead. The lead collects in the bottom of the furnace and in so doing recovers copper and precious metals present in the charge at a high efficiency. The remainder of the furnace charge, that is gangue, coke ash and fluxes, forms a molten slag. Lead and slag are then tapped into the forehearth to be separated. The mixture of furnace gases and zinc vapor, which rises to the top of the furnace shaft, has a temperature of about 1,000 degrees centigrade and contains approximately 5 to 7% of zinc by volume. Furnace gases and zinc vapor then pass into what is probably the most interesting feature of the process, into the lead splash condenser. This condenser consists of a bath of molten lead into which rotors are immersed. These rotors produce an intense rain of lead droplets within the condenser. The zinc vapor passing through the condenser is shock-cooled by the lead droplets from 1,000 degrees centigrade down to 450 degrees centigrade, and is at the same time dissolved in the molten lead. Zinc not dissolved by the lead droplets and the furnace gases leave the condenser and pass to a water scrubbing system. There, the last traces of zinc and lead are recovered in the form of blue powder. The cleaned furnace gases are then available for preheating the coke and the air used in the process. Back in the condenser, the solution of molten zinc and lead is pumped from there into a water-cooled launder. The cooling separates the molten metals, and zinc, being the lighter of the two, floats on the surface of the lead. It's then a relatively simple matter to run off the molten zinc from the underlying lead. This operation takes place in the separation bath, where zinc and lead collect as separate layers. The zinc then runs off into a holding bath, from where it's periodically tapped into a ladle for casting. The molten lead in the bottom layer of the separation bath flows back to the lead splash condenser to be used again. Sinter used in the process is produced in a separate sinter plant on this updraft sinter machine. Leaving the sinter plant, the sinter is self-fluxing and has the necessary mechanical strength and the required chemical reactivity. Metallurgical coke, the other raw material required for the process, is transported on belt conveyors into the charge proportioning plant. This charge control room is the nerve center of the proportioning and weighing system. From here, all furnace charging operations are remotely controlled and recorded. What happens each day at Swansea represents the fulfillment of an ambition of long standing, because zinc metallurgists all over the world have made many unsuccessful attempts to smelt zinc in a blast furnace. The achievement of the Imperial smelting process is comprehensive, for the process is not limited to the treatment of high-grade ores, but can handle low-grade and complex materials which earlier processes could not. Furthermore, it's the only process in which zinc and lead can be treated simultaneously, the lead being produced virtually cost-free. Compared with the old horizontal distillation process, which employed large numbers of small retorts, the Imperial smelting process uses only one large single unit of high productivity. Practice at Swansea and elsewhere now reveals the capacity of the process for bulk handling of materials by employing automation and mechanization. The resultant small labor requirement helps considerably to lower cost of production. This is the shaft of the Imperial smelting furnace, the centerpiece of the whole process. A furnace of this size is capable of producing 120 tons of zinc per day, and up to the same amount of lead bullion as well. This is the control room for all operations relating to smelting and condensation. The 550 horsepower blower compresses the blast air. The blast air is then brought up to 750 degrees centigrade in the air heater, which is fired by blast furnace gas. The blast air enters the furnace through these tuyeres, which also permit a glimpse into the combustion zone. Tapping the blast furnace is the only operation of the new process resembling the laborious though colourful older method of zinc smelting. After tapping, the molten lead from the forehearth is cast into 1-ton ingots, which can then be treated by conventional refining methods. Inconspicuous as it may appear from the outside, this lead splash condenser is the very essence of the Imperial smelting process, because it's here liquid zinc is recovered from the blast furnace. Dross, a byproduct of the process containing zinc and lead, is removed from the condenser and then recirculated to the sinter plant. Blue powder from the scrubbing system is recovered in this door thickener and also recirculated to the sinter plant. These are the launders in which the actual separation of molten zinc from molten lead takes place. It can be seen how the zinc droplets form a fine stream floating on top of the molten lead. After the zinc has been tapped from the furnace holding bath, metallic sodium is added in order to remove arsenic. The zinc is then poured into the holding furnace, where it's kept at casting temperature. Zinc slabs are cast by machine, a further example of the extent to which mechanization has been employed in the process. Zinc production in a blast furnace combines high productivity with flexibility and low operating cost with low capital cost. Because of its flexibility in treating a wide range of materials, the implications of the Imperial smelting process reach far beyond the smelter, affecting current milling and mining methods as well. Therefore, companies in all parts of the world have already proved receptive to the new process. Europe, France, Noyelles-Godeau. Société Minière et Métallurgique de Peñarroya is replacing its horizontal distillation plant at Noyelles-Godeau by an Imperial smelting furnace. A part of the Peñarroya company's lead production will also be diverted to the new installation. Africa, northern Rhodesia, Broken Hill. The Rhodesia Broken Hill Development Company Limited mines a zinc and lead deposit of very high grade. But by older processes, the recovery from the ore was disappointingly low. An Imperial smelting furnace, commissioned in January 1962, raised the production of zinc to approximately twice its former amount. This was done without the need to increase the mining rate by using dump and residual materials left by other processes. The same applies to lead production at Broken Hill, where the former lead smelter consequently was made redundant. Australia, New South Wales, Cockle Creek. Sulphide Corporation Proprietary Limited commenced production of zinc and lead at Cockle Creek in August 1961, installing an Imperial smelting furnace which treats materials from the Australian Broken Hill mines. Protected by worldwide patents, the Imperial smelting process is finding wider and wider adoption. Blast furnaces for zinc and lead production are being installed in many countries all over the globe. And while development work on the process goes on, they make more and more zinc at Swansea.